Longer leg of a right triangle is 7 meters longer than the shorter leg. How long should the shorter leg be to ensure the hypotenuse is at least 13 centimeters? So first, we're going to draw the given triangle. Since it is a right triangle, so there must be a symbol of right angle in our triangle. Now, in our given, since the longer side, so let us identify first the parts of this triangle. This is the shorter leg. This is the longer leg, and the longest side is called the hypotenuse. Now, since the longer leg is dependent to the shorter leg, so we must go first to our shorter leg. What is the measure of our shorter leg? Since it is not given, we will set x to assume an unknown number. So if our shorter leg is x, it follows that our longer leg is x plus 7, since it is 7 meters longer compared to the shorter leg. Then our hypotenuse, or the longest leg, is more than or equal to 13. Now, so this is the label. So this is our shorter leg and this is our longer leg. Next is to set up an equation that we're going to use. Since according to the Pythagorean theorem, the sum of the square of the shorter leg and the longer leg is equal to the square of the hypotenuse. So we can set up an equation like this. Okay, so we can square the shorter leg, square the longer leg, and square the hypotenuse. We are going to find their sum, and it must be equal to them if it is a right triangle. Now let's go. So let us simplify this one. Write down x squared. Then for this, x plus 7 squared is x squared plus 14x plus 49. Then write down more than or equal to symbol. Then 13 squared is 169. Then x squared plus x squared is 2x squared. Write down the other terms. Then minus 169 to both sides, so that the other side becomes 0. And positive 49 minus 169 is negative 120. We want our a to be 1. So we can cancel this by dividing each side of the inequalities by 2. So that this one, 2 divided by 2, x squared is left. 14 divided by 2 is 7. 120 divided by 2 is 60. 2 is 60. Then 0 divided by 2 is 0. So it is now simplified into quadratic inequalities. We are now going to use our skills in solving this one, like what we learned in our previous videos. Now, let's start by setting a boundary. Okay, so this is our given. The first step is factor them. Then after factoring them, equate each binomial to 0. So I just changed the inequality into equal sign. So each of the binomials, so let's start from the left side equation, minus 12 to both sides. So x is left, then 0 minus 12 is negative 12. On the other side, plus 5 both sides, x is left, 0 plus 5 is 5. Now, after getting the boundaries or the critical values, the next thing to do is we're going to plot these critical points to our integer number line. So I uses a shaded circle. Just assume that it is a circle. It is shaded because the given is more than or equal. Okay, so because of these two boundaries, our integer number line were divided into 3 regions. Okay, so we can name this first region as x is less than or equal to negative 12. Then the center region is x is more than negative 12, but x is more than or equal to negative 12, but less than or equal to positive 5. So that's the boundary. Okay, and lastly, on this side, that is x is more than or equal to positive 5. Then next is we're going to test each of these inequalities using the simplified form. Although you can use the original given, but I always advise to use this one because it is easier to solve using this simplified form, the factored form. Now, if x equals negative 13, although you have an option to choose any of these values because all of them, they represent these inequalities. But I prefer to use a smaller number than negative 13. The number closer to 0 because it is easier to use. So if x is negative 13, if we're going to substitute negative 13 to these inequalities, you will get 18 is more than or equal to 0. Is it true? Yes, it is. Okay, so using these inequalities, if x equals 0, since 0 is a part of these inequalities, and 0 is easier to use. If we're going to substitute it here, we will get negative 60 is more than or equal to 0. Okay, let us ask ourselves, is this correct? Is negative 60 more than to 0? No, so it is false. And lastly, for these inequalities, in this region, I prefer to use 6. So if 6 is replaced here, we will get 18 is more than or equal to 0. Is it true? Yes, it is true. So therefore, only this equation, the blue one, inequalities, and this green inequalities satisfied our given equation, our inequalities. So it tells us that this is not the inequalities that satisfies the equation. It means the answer is not cannot be located in this group of numbers. Only this group or these inequalities and the other inequalities. But since we are looking for the length, the question is how long should the shorter leg be? So it means we're looking for the length. And when it comes to length, there is no negative measurement. So it means we will also disregard this one. Although this inequalities satisfies to our original inequality given, since we are looking for a positive numbers only because we are looking for a distance, so disregard this one. So only this one is accepted. And for our answer, so if we're going to write our answer in graphical way or graphical method, this one will be our answer in graphical way. So in inequalities, so we can write our answer as x is more than or equal to 5. Just copy this one. Or in notation form, it must be positive 5 going to positive infinity. Okay, so to answer our word problem, so the answer must be, since the question is how long should the shorter leg be to ensure the hypotenuse is at least 13 centimeter, the answer is the shorter leg should be more than or equal to 5 centimeters to ensure that the hypotenuse is at least 13.